1, F through J. So letter F, let's go through that one first. Alright, Chris.
Nitrogen and dioxide.
Ooh, just nitrogen?
Oh, dinitrogen.
Dinitrogen.
And dioxide.
Good job. Alright, letter G. Ethan, what you got?
Iodine, chloride.
Good job. Number, well, I keep saying number. Letter F.
Iodine chloride was iodine monochloride.
You can, but sometimes they leave it off if it's understood to where they don't have like a reoccurring one for this one. So like carbon monoxide and carbon dioxide, because those are so different, they make sure which one are you talking about. So carbon monoxide.
Because I thought it was just the first letter that you don't have to do it.
Traditionally, you don't have to put it on there, but it's one of those, if it's to where you need to get it distinctly different, then that's the reason why we put mono. But it's one of those, yeah, it's understood that you don't have to put mono, because if you're saying the name, it's understood that one's already there. Alright, letter F. Alright, Chris.
F, you mean H?
Yes, sorry.
Oxygen difluoride.
That's it. Alright, I, Ethan.
Xenon, tetrafluoride.
That's it. Alright, J.
Phosphorus triiodine.
Iodine or iodine?
Iodine.
There you go.
Triiodine.
Alright,
Or iodine, but I mean iodine.
remember, so remember the N changes to the
I
I.
think the I and E just kind of mixed me up. Because like it looks like IDE now.
Twice.
Yeah, so just be careful with it, with pronunciation, make sure you get all the parts for it. Alright, letter 2. So E through H. Alright, we'll start with Ethan this time. Alright, Ethan, what you got?
S2F2.
That's it. So S2, F2. What do you have for letter F?
BR2O1.
Good job. And then for G, Ethan, what do you have for that one?
A2O4.
That's it. Alright, Chris.
P1CL3.
Good job. Did you actually write whenever you're writing it? Are you writing it like that, where you have one down here? Alright, you don't have to do that because again, it's understood that, okay, if it's there, then it's an understood one for it. But yeah. Alright. Anyone
It's
have
not going to lose points if I do that.
Yes, you might. Now, keep in mind that there is a proper way to do it and a non-proper way to do it. So it's one of those, I understand what you're doing, but scientists are going to look at you and going to ask you, what are you doing? Why are you doing it like that? So it's one of those, that's not necessarily, are you going to lose points for it? But something to where there is a correct or an incorrect way to do it, and scientists are just going to basically look at you and want to know, why are you doing it that way? Because it's an understood one. Okay.
Like, realistically, how much do you use chemistry outside of, if you're not a science teacher or you are a chemist? Like, how much do you use it outside of the rule?
Every single day. For cooking. That's what chemistry is. Whenever you are combining different ingredients together. Now you might not, depends on what you're doing for it, but I mean fertilizers. If you're gonna work with plants at all and want to use fertilizers, the numbers on the bag tell you how much of a particular compound that you need for it. So you might not be writing out the elements, but if you're looking at like an alcohol bottle and it says like it's 2% alcohol, like rubbing alcohol, that tells you how much concentrated it is. So it's one of those, you might not work like directly with these numbers, but they'll put typically the symbols on the side of it to let you know of like this, hydrogen peroxide, they'll want you to know how much of it is active hydrogen peroxide and how much of it is diluted. So it's something where, okay, yeah, you need to recognize it. Now, are you gonna write it out every single day like this? Okay, probably not, unless you wanna go specially into something that uses it, or if you're gonna be like a pharmacist, okay, you use chemicals all the time for that one. So it just depends on what you're getting into. That's one of the reasons why we teach it to you, so that way your careers are open. You can do a bunch of different things. You're not just limited because you don't have the knowledge. Knowledge is like tools, so you want as many tools as possible, so that way you can go do a whole bunch of different things. If you don't have a lot of tools now, it's gonna be a lot harder later on. Alright, anyone have any questions about this though? Alright, before we watch the lab, I just want to make sure that we're going over with the naming for it. So remember, what are you supposed to be memorizing on page 40? Ethan?
Anions and anions.
Good job. So make sure you're working on it. It'll be about, by the time we come back from the break, it'll be about a week and a half, about a week. So make sure that you're at least working on them a little bit, or you're mentally preparing yourself to, I need to start working on them and get ready for it. Alright, so what does, thinking back over it, what do we call the numerical relationships between elements and compounds? What do we call that science of numerical relationships? Yep, you were asking about this earlier. Alright, there are chemical formulas. There are two basic types. If it's an ion, what type of chemical formula is it? Ethan?
Ionic.
Yep, so an ionic compound, the other one is a molecular compound. There are three different ways we can kind of write them out with these chemical formulas. What is the type of formula that tells how many of each type of atom are found in an actual molecule? Ethan. Chris.
Is it,
Like this, whenever you're writing out to saying, okay, how many are there?
that's either imperial or it's either imperial or it's, what's it called? It starts with an M, right?
It does. These are molecules.
Molecule, yeah.
So molecular formula.
Yeah.
Molecular formula. Alright, whenever we're talking about a ionic compound, so like NaCl, just to keep it basic. Alright, what type of formula is that to where you're given the smallest ratio, Ethan?
Imperial.
Empirical, and then if it is a ionic compound, we'll have kind of like a special nickname, kind of other name for it as well. But you all right there, it is empirical. Do you remember what the other one is? Do you remember, Chris? What?
What does it start with?
F.
F?
F.
I don't remember.
Alright, formula unit is the other name for it, but empirical formula is the type, but if we're talking about ionic compounds specifically, we call it the formula unit. Alright, so thinking about the prefixes, what means one? Hopefully these are easy.
No. Mono.
Mono, what means two, Ethan?
Yeah.
That's it.
Tri.
4.
Sour.
Starts with T.
Tetra.
Tetra.
It starts with
P.
Penta.
Penta. 6.
Start with
H.
Hecton.
Hepta or hexa?
Hexen.
Hexa. 7.
7 would start with,
H.
is it hepta?
Hepta. Alright, 8.
Off.
9.
Oh, is it like name? What's start with?
N.
Is
It's
it
a little
nano?
bit harder if you don't know these.
9. Is it like Nexo?
Not quite. Ethan, do you remember? Alright, Nana. So N-A-N-O. So yeah.
That's what I said.
I can't hear you. You have to speak up and take your straw. I don't know what you're talking so I can hear you more. So wait, it'll help me to hear you. And then what's the last one? Ethan.
Diaz.
Okay, that's Spanish. What is it for the prefixes?
I don't know. What's that one?
Starts with D.
Yes.
Is it Deca?
Deca. So just make it up. Deca.
Decalog.
If that helps you to remember, that's fine. Or like decibel because we count in powers of 10. I mean, whatever helps you to remember for it. Alright, whenever you're naming a binary molecule, what do you call that? How do you name it? Like if you were to name, and this is what your homework was over, so we're just gonna make one up. I think that can happen. Nope. That can happen. Alright, so what would you call this molecule then? What's the first one? How do you name it?
Carbon. Tetrafluoride.
Okay, I wanted just carbon, but that's fine. So carbon tetrafluoride. So good job remembering to change the ending. Good job remember changing the ending to the I. I'll give you another one. Silicon will
Ethan's
work.
always learning everything for me.
We'll do this. That'll work. Okay,
Silicone tetrafluoride.
good job. Alright, so remember, these typically are with non-metals because of how they share them. So typically, we see this with a non-metal group. Alright, we started getting into cations and the ions, but then we ran out of time. Alright, I'm going to go ahead and stop there so that way Jamie has enough time and Quentin has enough time to watch the lab video as well. So, the lab lesson, Jamie and Quentin, is on lesson 16, so it's a little bit back there, so you're going to have to go find it. It's lesson 16. You can skip the beginning homework if you want to. If you want to watch it, that's fine. But you can skip the beginning homework, so that way it'll save you time as well for it. Alright, so go ahead and take out your assignment pads so I can give you the homework since it is different than the one in the video. So everyone go ahead and take out your assignment pads.
Un momento, senora.
I don't have
You're not married. You're not married. Senorita.
Thank you.
I don't know why.
Okay, that's
Okay.
all good.
One of the junior I's official, they just keep calling me Mrs. Morse, and that's how
I think it's because everyone,
Pretty much
I guess everyone
every-
else in the school is Mrs.
Yeah. Well,
You're the
Mrs.
youngest though. You're also the youngest.
Anyway.
The youngest teacher.
In the school?
Like in the secondary.
Okay, yes. Alright, so your homework is to make sure you turn in the lab report sheet on Tuesday. It's officially due Tuesday, so Jamie and Quentin, if you want to watch it later and then come back to it, you can. Just make sure you have it ready to be turned in on Tuesday. Everybody else, if you want to turn it in today, you can, but remember, it's not due till Tuesday, so if you don't finish it, make sure you finish it by Tuesday. And that is it, and enjoy the rest of
Lab
your
report sheet
holiday.
5?
What?
5?
What?
5?
Lab 5.
Um,
So make sure you get it all done. Alright, anyone have any questions about the homework?
is